Good afternoon, everyone. We welcome you all to the final technical session of the conference. The human brain works as a binary computer and can only analyze the exact information based zeros and ones. Our heart is more like a chemical computer that uses fuzzy logic to analyze information that cannot be easily defined in zeros and ones.
I now call upon Dr. P. Satish Mohan Sir, Assistant Professor, Department of Mathematics, Kongunadu Arts and Science College, to introduce the keynote speaker, Dr. WOJCIECH, who is here with us to deliver a presentation on the topic Decision Support Systems using Fuzzy Logic. Sir, please.
Good afternoon to all. I welcome Dr. WOJCIECH received for this international seminar. I welcome you, sir. A small note on sir. Dr. WOJCIECH sir received his PhD degree in Information Technology and Computer Science from West Pomeranian University of Technology, Poland in the year 2018. From 2019, he has been serving as an assistant professor and head of the research team on intelligent decision support systems. He is the author of more than 110 scientific papers and more than 650 peer reviews. His research interest includes soft computing, multi-criteria decision making, and artificial intelligence methods. He has been a member of the IEEE for 9 years. His works were cited almost 2000 times and H-index were 29. Once again, I welcome you, sir.
Sir, kindly take over the session.
Hello, everyone. Do you hear me?
Yes, Professor, we could hear you.
Yes.
Oh, great. Okay. Now you should see my presentation. Okay. You see my presentation?
Yes, sir.
Oh, great. Hello, everyone. One more again. My name is Wojciech Sałabun. I'm from research team on Intelligent Decision Support System and Department of Artificial Intelligence and Applied Mathematics, Faculty of Computer Science and Information Technology, West Pomeranian University of Technology in Szczecin. And today I have a great honor and pleasure to present my work about decision support system using fuzzy logic. We have some slides and not so much time, but I want to explain everything in details, if it will be, of course, possible. Okay, and we start. First, I want to present some works where everything was started. The first A1 works is the official first paper about characteristic object method, a new distance-based approach to multi-criteria decision-making problems. When we're talking about decision support systems, we very often thinking about machine learning, about another artificial intelligence method, but I will talking today about multi-criteria decision making problems, about multi-criteria decision analysis. And here we have some literature about the content of our presentation. We have here some papers in A6, for example. This is near 9 impact factor paper, the high impact factor papers. This is the set of conference. And of course, it will be available after our conference. You can read it. You can find more information in these 10 papers. This is the thing about decision support system using fuzzy logic. I will describe the characteristic object method, which is the very important part of building a reliable decision support systems. Yes. Okay, but first we should start about define decision support system. Yes, DSS very often, as I said, using multi-criteria decision-making methods. Yes, this is a very important when we have decision, when we have not always objective assessments. Sometimes we need an expert. The expert have their own exploration, and then very often we have a little problem because we have someone who is an expert, but we don't have explicit decision-making function. And how we can solve this problem? We should identify the decision-making model, decision-making function, but this is not trivial. Very often, when we have decision based on data, this is more easier. Why? Because we have a data and we can compute some answers. When we have something like problem with the expert, and the expert is the most important part of our system, then we need the decision support systems. And when we create decision support systems, we need a correct method. And this story is starting from which method is better and why we need one more method, a new method. Of course, decision support system and multi-criteria decision making, we need at least two criteria. Of course, these two criteria will be very often opposite. We will have the first criterion when we want have as big as values as possible, and second when we want the lowest value. And it will be the two types, benefit and cost. The benefit, it means when our value is growing up, the preference is growing up too. When we have the cost, when we have value which is growing up, the preference is going down. Okay. And the expert must evaluate the selected set of alternatives. This is the main problem to solve, because very often we have a set of some alternatives and we have to find the best solution, the best order, or something like that. Okay. Where is the problem? The problem is very small, because we have the hundreds of MCD methods. When we counting the classical method and the extension, we have 1,000 of methods. Sometimes we have one paper method. It means that we propose, or somebody propose a new method, and this new method is only using in this one paper, and nobody want to use this method anymore. Why? Very often this is too complex, too difficult, or we don't have so much benefits as we want. Okay. And okay, and we have the problem that we have still a new methods and their extensions. Therefore, we should look on some data. Here we have only short period from 2007 to 2016. This is the Web of Science base. The base of impact factor papers or core collection, and we only see here the 5 classical methods. Analytical hierarchy process here, HP, yes, is the most often used method. After that, we have autopsies, Electre, Promete, and analytic network process. As you see, it means that in each year we have 1,500, 800, 200 papers where we used this method. Yes, we used this method, and we have linear regression, which is very clear. The number of this paper is increasing. Yes, and we can of course look to the another base, for example, Google Scholar. We have the same observation, but the number of papers is 10 times greater. Yes, we have 16,000, 2,000. This is a great number of papers. Yes, about only these 5 methods. We have more methods. Yes, this is without the fuzzy logic. Yes, therefore we can say this is a big number. In multi-criteria decision analysis area, we have 3 basic areas. Alpha, this is a selection problem when we should find a subset or the best solution. Why the best is here right in this way? Because very often we cannot say that something is the best because we will not have the formal proof, but we are looking the best solution where we have no in our mind optimal, because we have Pareto optimal subset of alternatives, and we should find a subset. It can be one element subset, but we must looking for some alternatives which are the best. It is the most reliable solutions, alternatives, and this is the classical classification where we can find it in the Bernard Roy works. And beta sorting problem, yes, we have to ordering our set of alternatives and problems of ordering, yes, construction of a ranking of the variance of set. And what is here the difference? Here beta is more like classification, because we are sorting here to predefined categories, predefined classes. Yes. And what next? Problem of ordering is very easy to understand, because we have to get as the final result ranking. And what next? Next thing, this is what was the motivation to undertake this research. I said that we have a problem, that we have many methods, and we also indicate the negative, the shortcoming of this method. The first and the biggest one is the rank reversal paradox. It will be described in the next slides. Next thing is the accuracy of MCD methods, because when we are using method, we are believe that this method is correct or useful, but we should know what is the accuracy of this method. Next, we can describe, we can find, identify the local weights or global weights of our criteria. Which criterion is more important, which criterion is less important? This is still very important. After that, we have how to choose the right weights, because when we have to solve some problems, we should identify our vector of weights. And first question is local weights or global weights. What is the difference? If we have two alternatives, they can be put in other point in our space of the problem, and now we are thinking, okay, the local weights, it will be something else than global, because global is something like mean of all local weights. In local weights, I won't say that sometimes if somebody have a good salary, and we have two criteria. He or she is looking at work, and we have two proposals. And then, if we have this proposal, there is a correlation between these two criteria. For example, the salary, the amount of salary, and time what you should involve to your work. Yes, of course, we have here the correlation, and this is the point number 5. Sometimes some methods not include the correlation between two or more attributes, and there is everything calculating as separate data. Yes, and these challenges was the mayor's challenges for creating the Comet method. And if we're talking about rank reversal paradox, where and how we can describe it? Okay. Actually, we have 5 basic types of this paradox, yes, but always we observe the same effect of this paradox. What is it? We have, for example, the 3 alternatives. Let's suppose it is A, B, and C. And we're using the method X. We don't know which method, but this is still the same method in all this slide. We have the method X, and we get this order. A is the worst, B is better, and C is the best solution in this set, okay? But after that, we have a second problem. When we have 4 alternatives, this exactly the same A, exactly the same B, exactly the same C alternative, and last one is D. D, this is the new one. It means that we extend our first set by adding one new alternative D. What we get? We get something like that. And we are using exactly the same method. Exactly the same method. Okay, what is here not proper or not... what is the problem? The problem is that if we, looking on the left side, we have a relation that C is better than A. This is true. But here we have relation that A is better than B. But in previous calculation, we had A is worse than B. And now we have a problem. What is better, A or B? And where is the start of this problem, start of this paradox? Because many methods using the alternatives to creating the space of our assessment, yes? Therefore, when we change by adding or removing some alternatives, be changed. Of course, not in this manner that we get a new alternative. We get a new alternative, it's obvious. But in the old relation, C, but here we have a rank reversal. And we have the same effort, only one difference. Here we have 3 alternatives, here we have 4 alternatives. Okay, what next? The second thing is accuracy of MCD method, and we have here some preliminary works. One of these is the typical work when we have one method in a given context and we want to assess accuracy. This is Zawadzka's. His works are very popular. He has very many works in the area of fuzzy methods in MCDA, multi-criteria decision analysis methods in general. Yes. And we have here evaluation of ranking accuracy in multi-criteria decisions in journal Informatica. Okay. Sometimes we have something, what we can say, most extensive research on accuracy, the MCD methods. And First, something that make the professor change the fellow. This is the professor from United States of America, and in his work there was TOPSIS, AHP, and two more methods. But after that, a huge problem was that nobody continuing his work. And here we have one of our last paper, when I and my team, Professor Wątróbski, it was your keynote speaker yesterday, I guess, and we make RMCD methods management cable, a comparative study of TOPSIS, VCOR, COPRAS, and Prometei 2 methods. This paper got a very good impact because this is only 2.5 impact factor paper, but it has something like 90 sitting sites from the past year. Yes, this is only 1 year and 90 citations. And what next? We have also more problems, as I mentioned before. We have problem with determining significance weights. It means we have some criteria. What is more significance? What is less significance? How to do it? This is a huge problem. The next one is whether these weights are constants or it can be variable in the space of the problem. Next problem is in many methods, criteria are evaluated separately, what I mentioned before, and there is no synergy effect. There is no consideration of the relationship between decision attributes. The separately used criteria we can observe, for example, in analytic hierarchy process, which is very, very popular, as you saw on our figures. Okay, and this was the base to create and propose the characteristic object method. The characteristic object method, the acronym, the Comet method. Okay, and when we're talking about the algorithm, it's very simple. Maybe it will be too simple when I start explain, but I have to explain it in details. First, defining the problem space. Second step is generating characteristic objects. Next step is ranking of characteristic objects. Next is linguistic model. We obtain it in step number 4, the linguistic model. And based on this, we can evaluate the set of our alternatives and we get a final ranking. And now, to better understand this method, I want to present the theoretical explanation of each step, and after that, we will have the numerical example. And this numerical example, it will be assessment of kidney function based on a glomerular filtration rate. This is GFR, this is the index, and medical index, and the ability of the kidneys to filter blood plasma into what is called primary urine. Of course, it means it can be using for the transplantation systems. We have one work about, for example, Professor Lascalia make the work about the problem of transplantation pancreatic islet, and it was also very important work. There is used the TOPSIS method. However, TOPSIS method has only two characteristic objects, the positive ideal solution and negative ideal solution. In our proposed method, the Comet method, there can be used more characteristic method than two, and they are not always related to our decision matrix. Okay, let's start. First, defining the problem space. Okay, what we have here. Our final result should be, for each criterion, we should have a definition of characteristic values. For example, when we have R 1, 2, 3, 4, and so on to R number of criterion, for each criterion we have to get the characteristic values. Yes, and what we have here, we have a linguistic variable. Here we have a linguistic variable. Next R is the number of linguistic variables, as I said. And here we have C1, C2, CR, number of triangular fuzzy numbers, because on the base of these characteristic values, we will have something what we can call triangular fuzzy numbers. Okay. And when we want get the linguistic variable and their domain in our example, we have to choose 3 component criteria, and it will be patient age, and we have the first two characteristic value, 40 and 70. C2, it will be body weight, it will be from 60 to 125 kilograms. And this is also our first 2 characteristic values. And after that, we have the C3, criterion number 3, serum creatinine between 20 and 100 micromole per liter. Okay, and we have 3 criteria, and for each 3 criteria, we have 2 characteristic value, the minimal possible value and maximal possible value. Of course, we can say, hello, but the patient age can be, for example, 55, 57, 54, or we can get the people who is older, 80, 75. Yes, but we have here very, very important assumption. Our assumption is the space of working our model. And here, after the speaking with the doctor, medicine doctor, we have that this problem is very often for this time domain people, this weight and this creatinine. If we have something what is a bit bigger value or smaller value, it is not typical value, and therefore for us it's not very interesting. It is interesting, but it will be just another model. Okay, our model will be working here. We don't want to make extrapolation, therefore we assumed that each patient age will be in this interval, in this weight, and this creatinine serum. If we want more wider interval, it's the time to change it. Okay. And for example, we have here the visualization of our characteristic value. The first characteristic value for the age, it was 40 and 70. And here we don't have any more information about that. We have any more characteristic value. Therefore, we adding one more in our average, in our medium of our interval. Yes, and we have 40 to 55, 55 to 70, and we have 2 equal length intervals, and then we have fuzzy triangular numbers. The first fuzzy triangular numbers is C11. The second one is C12. Here we have the level of membership function. Yes, here for C12. And the third one we have here. This is this one. And what it means? It means a free linguistic concept. Here we have the human who have around the age around 40 years. Here we have around 55 years, and here we have the human with the around 70 years. Okay, and what is a membership function? Very quickly. For example, when we take the human who have 45 years, we can say that here we have somebody who is young, this is medium age, and this old person. When we have 45 years, we can read on this axis that we have two concepts. Because when we're talking about concept a young, this concept is going here, and we are reading it here. It will be 2/3 membership value. It means that if somebody have 45 years, if somebody have 45 years, he is young, and the membership function for the word young is 2/3. Next, here we have in medium age, it will be 1/3. Yes, it will be 1/3. And when we're talking about old, it is 0. Yes, because here we have this this function, and we have something what is not a classical logic. This is fuzzy logic, because 45 means that this person, this human, is in 1/3 in medium age, but in 2/3 is in the young age. Yes, this is in one part. He's around 55 and he's around 40. Yes, because here we have a partial true, and here we have a partial true. Around 40, it is 2/3. Around 55 is 1/3. And the same things we have here. However, if we're talking about the body weight, in our research, we take that we have interval from 60 to 125, but we have here the characteristic value because the people in this situation, when they have a problem with kidney, they have very typical 80 years. This is our domain. This is dominant, and this is our mode. Yes. 80 kilograms, and therefore we have 60 to 80 and 80 to 125 two intervals. We have three characteristic value: 60, 80, 125. Yes, and what next? Next is that we have three triangular fuzzy numbers, and in the previous example, and here we have example for the creatinine. And we have here 1, 2, 3, 4, 5 characteristic values. Okay, great. This was what gave us our expert. After that, we should generating characteristic objects. To generating characteristic objects, it's a very simple operation because we have using the Cartesian product of cores of these triangular fuzzy numbers. It will be something like that. Yes, it will be something like that. And in our case, of course, we have characteristic object, which is a multiplication of number of all characteristic values. And when we return to the first our figure, we have here 3 numbers, characteristic values. Here we have a 3 characteristic values, and here we have 5 characteristic values. It means that here we have 3 multiply 5, it will be 45 characteristic values. We define it, yes, we define it, and it's a set of 45 generated characteristic values. Yes, we have the young people, the medium age people, we have older people, and we have characteristic object number 1, years 40, weight 60, the creatinine 20, and so on. And these triplets are our characteristic values. We have 45 characteristic values, and this is the space of our problem. When we have here these crosses are our characteristic values, and here we have our domain C1, C2, and C3, age, weight, and creatinine. Okay, next level is ranking of characteristic object. Okay, the next we have to make ranking of this characteristic object, and we are creating the matrix of expert judgment, and we have some elements here. It will be T. The dimensionality of this matrix will be T on T. Why? If we return here, we have that this is the number of our characteristic values, characteristic objects. If it is the number of characteristic objects, it means that matrix of expert judgment, it will be comparison, pairwise comparison, each characteristic object with each one. Yes, and we have this definition of each element of our matrix. We get the function when we comparing the I characteristic object with J characteristic object. And then we have a three possible answers. The first one is that the I characteristic object is worse than J. They are equal, or the first one is better than second one. And then we get 0, 0.5 point, and 1 point. And F with the lower index exp, this is our symbol of function of the expert, a mental judgment of expert. It means that this part is made by the human, by our expert. He compares, and if he thinks that the first object is worse than second, give 0 point in this point. Okay, and now when we have our properties, we can say that when we compare to the same elements, we get always 0.5 points, because we always have what? We always have here our draft back. Yes, and after that we have if we have element when we inverse the indexes, we have this relation. Yes, therefore it's not so many queries because we have to complete only the upper or lower triangular matrix. Yes, therefore the number of our comparison, it will be this. Of course, sometimes it will be very big number. In our case, it will be 45 multiply 44 divided by 2. It means that it will be 45 multiplied 22. Okay, it will be 990 comparisons, 990, almost 1,000 comparisons. Okay, and what next? Next thing is that we have to calculate summed judgment vector Sj, and for each row we sum all points. For this we can using this procedure. This is the pseudocode which is written in MATLAB language in this case. And what we are making here, we are creating from this vector Sj vector P. And this is our vector of the preferences, and we are giving here the singleton, and we are giving the next value from 0 to 1, where 0 is not preferred, 1 is the most preferred, and we giving for each value Sj the next value in the interval 0 and 1, and we have the equal distribution of these points in this interval 0 to 1. Okay, and for showing this, we were using the idea of theoretical decision argument to represent the mechanism of the method, the glossary filtration rate, GFR, will be using. And it will be used instead of the real expert to show why we have something like that. And please see, this GFR is talking about our kidney, it's good condition or not, yes, and we can compare it. If we have characteristic object number 1 and characteristic object 2, we see that characteristic object number 1 have a great bigger number than CO2. Of course, we don't have this information very often. This is only to explain how it's working. The medicine doctor, which is working with the kidneys, he looking on the first characteristic object and second, and this have in his mind. It means he knows that CO1 have more value than CO2. We don't need it. We only need it to showing how it's work. Okay, and then we get this matrix, and as I said, here we have, if GFR is bigger, this is better. It means that the patient, the theoretical patient, CO1, which have 40 years, 60 kilograms, and 20 micromole per liter, it's the person who is more healthy than sorry, it's my mistake. We are looking here for the person to transplantation. It means that his conditional is 3 times worse than this one, because here we have the person 40 years, it's good, 60 kilograms is also quite good, but the serum is 20 micromole per liter, and here we see that the serum is going up, and we have a five numbers. As we see, for us, it will be very interesting. For example, the 2 person, the characteristic object number 5 and number 10. Why? Because here and here we have the same creatinine serum index, the criterion number 3, but here we have another weight. It means that when somebody is more have more kilograms, his conditional will be worse. Okay, and so then when we compare these numbers, we get this main matrix. Of course, this matrix can be a huge matrix. Therefore, we sometimes using the graphical explanation when the red is 1, blue is 0.5, and green is 0. Okay, and after that we get Sj, the sum of points which get each of our criterion, and then we get the preference from the one. This is the most important to make the transplantation, and here is the most healthy person. Yes, okay. And then we get the linguistic model when we have very easy to write it, because we have, if somebody is near our characteristic object, then he is near our preference for this characteristic object, and we obtain it here. Yes. Okay, and next one we have, of course, in details. If somebody have criterion 1 near, around, criterion this, and so on, so on, so on, here we are using the Mandani model, Mandani inference style. And as you see, we have 45 rules, the fuzzy rules. And when we have this linguistic model, then we can show that, for example, here we have if somebody is near 40 years and have near around 60 kilos and near 20 micromoles per liter, then the preference for transplantation is this one, yes, and so on, so on, so on. And finally, the most important thing is evaluation of alternatives and final ranking. Okay. To evaluation it, we must compute the membership function for all value. Here we have the people, the person who have 53 years, 71 kilograms, and creatinine 159. And we have the whole process of calculating the membership function from our triangular fuzzy numbers. And after that, we have only these 8 activated rules. Yes, it means that there is no zero membership values. Okay, and what we make next? Next, we get our number of rules. Yes, this is our preference vector for each rule. Yes. And after that, we have activation degree. The sum of all activation degree, as in the Mandani model, we have always equal 1 in this situation, in these assumptions. And partial evaluation is only multiplication of these two numbers, and so on, so on, so on. Okay, and sum of partial evaluation, it will be our final evaluation. And for this man in 53 years, 71 kilograms, 159 micromole per liter, it will be 0.2068. And when we randomly choosing 20 patients, we can using the Comet method, and we can check the accuracy. Why? Because we have GFR, this index, and when we make the comparison, we see that the ranking from the Comet method and ranking from GFR, this is very, very similar. But please see, here we have a mistake. Comet say that is 7 and 8, GFR said that is 8 and 7. But please look, the difference is only 0.06. This is a very small difference. And here we have also 2 more differences. Okay. And as you see, this is pretty good model. But how to assess, we will talking about it, how to assess is this ranking is correct or how much is correct. What is the level of similarity? Okay, and here we have the Comet steps in the individual decision making. We have also more extensions of Comet method. As you heard, I have 110 papers, and more than half is about the characteristic object methods and the extensions. Practically all of them, or 90% of them, is about a very interesting thing, what is multi-criteria decision analysis. And here we have one more very quickly. Step 0, we initiate the process. We have to define the MCDA problem. As you see, I have a small problem because I forgot if we are looking the more healthy or more sick person in our research. Okay, and when we are doing it, we have to select an expert. After that, we have to determine the set of alternatives, and criteria. We have to select the decision criteria. When we have it, we initiate the process. We have this and this giving us the decisional matrix. This is our decisional matrix. Yes, this one is our decisional matrix. And what is very interesting, we don't using weights here. Weights in significance weights of criterion. And this is a very good benefit from this method, because we don't thinking what is more important, particularly directly. Okay, after that we have to modeling structure of the problem. We are determine the rectangular fuzzy numbers for each criterion, but actually we have to say about numbers. Which numbers? The characteristic values. After that, we are modeling of the problem by generating characteristic object. This is only the Cartesian product. And after that, we have the step number 3 when we generate when we have a pairwise comparison of all characteristic objects by using expert. I have to using the function to explain how it's working. And after that, we are created main matrix. We are calculating the preference value. And after that, we obtain the rule base. Each criterion is transformed to our rule, a fuzzy rule, and then we have the fuzzy rule base. And the last one is inferencing using rule base. This is only the Mamdani model, and then we get a final ranking. Okay, but we have one problem, because here we have a lot of queries to make, yes, because we have here something what is related to our problem with the course of dimensionality, yes. Here we have a number of characteristic objects, here we have number of linguistic variables. And this sometimes it can be a very huge number. And here we have 3 proposed approaches to reduce it. Indication of outliers values, using the hierarchical structure of the decision problem, and the axiom of transitivity using. And here we have the number of reduced comparisons. Okay, when we have a T number of characteristic objects, and we have H as the number of elements fully acceptable or fully unacceptable, what it means? We can say, okay, this person case and should be first go to hospital, or this man is the example that he is in totality healthy person. We can give the preference 1 and 0, and then we not have to compare it in the main matrix. And then we can calculating the number of reduced comparisons. Yes, here we have our delta when we have number of queries before reduction and after reduction. And then we have the percent how much we reduce our number of pairwise comparisons. And here we have a draw when we can see that here we have a number of our characteristic values, yes, and we assume, let's suppose that we have only 2 outlying elements, the best one and the worst one, what is very often very easy. 45 is here. In our GFR problem, medicine about kidney, we have around 10% less comparison. Okay, great. It's not enough for 10 characteristic value. It's around 40% reduction, but we want more. The axiom of transitivity, it's very easy. When A is better than B and B is better than C, then A must be better than C, just that. And we have a free mathematical function, very easy mathematical function, and we want to show the using of the axiom of transitivity. And we have something like that, the easy function. Here we have 2 criteria two criteria where we have a type positive. It means when the C1 is going up, the preference is going up too. When C2 is going up, preference is going also up too. And here we have non then we have the mixed example when we have the benefit and we have we have some more examples, and then we have something like that. Here we have a number of characteristic objects, and here we have the percent of reduction. Okay, here is quite good, yes, because we have near 50, not less than 56% of reduction. But here we have the same in our figure, okay? And this is the first function, the second function, and third function. But the best it will be when we using the hierarchic structure of the decision-making task. Here we have something like that. And we have to make 125 characteristic objects. When we suppose that here we have 5 characteristic values, here we have also 5, and here we have also 5. This structure giving us 125 characteristic objects. But if we divide it into 2 parts, yes, the same situation as here. We divide it in 2 parts as here. Then we have something like that, C1 and C2 generating us P1, and P1 is the input to the second model. We are making another structure, and therefore we have make here 25 characteristic object and here 25. Why? Because we have 5 multiply 5, and even when we have here 5 and 5 characteristic values, we have 25. In sum, we have 250 characteristic value, and as you see, we have this number, 92% less comparison, because this is only characteristic objects, and we have the course of dimensionality. This is the second example. When we have 6 input, we have more than 50,000 of characteristic objects, and here when we change the structure to this one, we have 25, 25, 25, 25, 25. We have more than 50,000, but here we have 50, 100, 125 characteristic objects, and then our reduction is 99.9997. Okay. And here we have another example. This is the example that we say about the pancreatic isolate. Professor Laskalia had in his research 90 criteria, and it is the example how we can divide it in the another structure. Of course, these criteria must be connected logically each other. Okay, and accuracy of the method. Accuracy of method, we have a new method which I proposed in the last year, yes, and it has also many citations, around 100. And we have 2 tasks, the task of selecting the optimal alternative and the task of ordering alternatives, yes. And we have some parameters of statistical and what we have here. For example, when we get a Monte Carlo method and we will looking for comparison the TOPSIS, HP, and Comet method in the this problem with the mortality patient with acute coronary syndrome, we get the good choice and not proper choice, which we have 99% for the Comet method. This is accuracy of Comet method, and 82% is for HP method, and for the TOPSIS is 69%. Of course, Monte Carlo it's near 50%. Okay, and selection task, we see here how it's related to number of alternatives. And here we have the Comet, and here we have TOPSIS and HP method. Okay, the similar situation here. Okay, and here we have how to compute our before mentioned parameters. We have WC, WS, the weighted similarity 92%, ranked Spearman is 94%, and other also are high. This showing that this is quite good method. Okay, and very quickly, because our time is almost done, advantage of the Comet method. First, fully resistant to rank reversal paradox. Second, full domain model. We get the full domain model. It means if we get a new data, we can using our model. In the rest cases, very often we have to calculating one more time the whole procedure. Next one, we have no directly declared weight vector. Everything is making in the pairwise comparison. 4, we have open tools. We can see the PyMCD library when we have not only the Comet method, we have more methods described there. And we are also handling here uncertainty. We have many methods, many extensions with using the intuitive fuzzy sets, assistant fuzzy sets, interval, and have some things about the Comet. We have in Pipey, this is the Python language. We can go to the interpreter and pipe install PyMCDM, and you have also the full documentation here, GitLab.com /mcda. Yes, there is also the possible help if you have any problems. There you can write there and you get the help. And even we have the online software. When we go here, we have go to DSS software, decision support software, and we have the Polish version, English version, and we have also manual. Okay, and here is some work when we have more direction with Professor Tabassum Rashid. We got the Hessian fuzzy sets and Professor Faizi. We are doing the group decision making for Hessian fuzzy set. Also, we have a triangular fuzzy numbers, normalized interval valued. We have very interesting problem of assessment electric bikes case study, and so on. If you want, you can go also in my profile, for example, Google Scholar, and you have there many materials about my works. And if you need, of course, you can contact with me directly. This is my email. Thank you for your attention, and I would like to apologize that I take 4 minutes more than I should. Thank you very much for your attention, and if you have any question, I suspect that we don't have time now, but if you want, you can write to me mail. This is my mail. Thank you for your attention one more time.
Thank you, Professor. Dear participants, if you have any queries, you can ask them. You can unmute yourself and you can ask the professor, or you can put it in the chat box.
I'm very glad that you like my presentation. I see that in the chat we have Many thank you. Thank you for your attention one more time, and it was pleasure for me. It was a huge pleasure for me, and if you need some information, I put my email one more time in the chat window. If you want collaboration or if you want any material from the not open materials, you can find help in my email. I would like to say thank you also for the organization committee for that I was invited. Thank you very much and have a nice day.
Thank you, Professor. That was an amazing presentation. It was so nice having you with us. Thank you for sharing your valuable ideas.
Thank you much. Thank you very much. Bye.
Dear participants, we have the valedictory function now. Please stay back. Follow the rhythm of your heart. Heart takes you to the destination where your goodness dwells. Warm evening to all of you once again. On behalf of the Department of Mathematics, Kongunadu Arts and Science College and Bannari Amman Institute of Technology, we happily welcome you all to the valedictory function of the International Virtual Conference on Mathematical and Computational Models, ICMCM 21. Sunshine is a welcome thing. It brings a lot of brightness. I now call upon Dr. K. Prakash Sir, Assistant Professor, Department of Mathematics, Bannari Amman Institute of Technology, to kindly present the welcome address. Sir, please.
Good evening to one and all present here. It's my pleasure to welcome all the participants today for validation of the 2 days conference organized by Bannari Amman Institute of Technology and Kongunadu Arts and Science College, Coimbatore. I welcome all the eminent speakers and guests from all over the country from different domains to share their knowledge and vast experience with the research community. Once again, I welcome all of you. Thank you.
Unity is strength. When there is teamwork and collaboration, wonderful things can be achieved. I now invite Dr. M. Paribala Ma'am, Assistant Professor, Department of Mathematics, Bannari Amman Institute of Technology, to present the report of the conference. Ma'am, please.
Thank you, Kartika. Good evening, one and all present here. This is Dr. Parimla, the convener, International Conference on Mathematical and Computational Models, ICMCM 21. These 2 days, 29th and 30th October, we have organized this international conference by the Department of Mathematics, Bannari Amman Institute of Technology, and Kongunadu Arts and Science College. I'd like to present you the report of the conference on this august occasion. The International Virtual Conference on Mathematics and Computational Model, ICMCM 2021, provides a global platform for academicians, researchers, students to gain the knowledge in the recent trends in the field of mathematics, computer science, engineering, and technology. 7 eminent professors with excellent knowledge in their domain from various countries delivered their ideas as keynote address. The day 1, we started with 4 eminent speakers. One, Dr. Adam Klickman from Malaysia. He delivered a talk on some applications of generalized functions and singular operators. Followed by him, Professor Muhammad Sajid from Saudi Arabia gave a talk on fractals. And Sanna Kadara from College of Technology Innovations, Zayed University, United Arab Emirates. She delivered an application-oriented talk on generalized adversarial networks and its applications. And the last session was over by WOJCIECH, University of Silesia, Poland, delivered his address on multi-criteria decision attributes methods in sustainability domain and its recent developments and challenges. Today, on the second day of the conference, Professor Dr. Subiano MS from Indonesia delivered his talk on computing max plus algebra and its applications. Then followed by him, Inan Unal from Turkey. He delivered on some applications of Riemann geometry in deep learning. Now, Professor Wojciech Salaban, Westportarian University of Technology, Poland, delivered his talk on decision support systems using fuzzy logic. We got International Technical Committee, which comprises of 12 expert members. Professor Al-Etik from University of Egypt, then Ainur from Turkey, Biju Vasudevan from Saudi Arabia, Professor Sinab Ozil from Saudi Arabia, Professor Florentine Marande from USA, Professor Ibtesam Al-Samari from KSA, Professor Intan Muchadi from Indonesia, Professor Medellini from Lebanon, Professor Muhammad Riaz from Pakistan, Professor Quayes from Iraq, Professor Said Brahmi from Morocco, and Said Jafari from Denmark. This conference was an international forum for the researchers and students who had an interaction with the eminent speakers and experts and debated the foremost recent innovations and findings in the field of mathematics, computer science, engineering, and technology. The expert team, this conference also helped the researchers to share and exchange their knowledge work experience through paper presentation and high quality research paper in the area of mathematics, computer science, engineering, and technology have been planned to publish in Scopus Index Journal 2. This conference has united around 720 academicians and researchers, out of which 67 are foreign delegates from 11 different countries like Algeria, Bangladesh, Cambodia, Egypt, Lebanon, Morocco, Nigeria, Pakistan, Philippines, Saudi Arabia, and South Africa. Around 250 research papers were submitted, and out of which we selected 220 research papers and are presented in the two sessions. For these 2 days, 23 parallel sessions were arranged for the paper presentation. An abstract booklet as a proceeding was published, which consists of the proceedings of the conference and the abstract of the submitted papers. Hope this conference has met all your research needs. Thank you.
Thank you, ma'am. It's always nice to get good feedback, and a bit of encouragement can go a long way. We kindly request the participants to convey their feedback regarding the 2 days international conference.
Good afternoon to everyone. Thank you so much for all your thoughtful information. The session was really informative and it will be very useful for all the young researchers. And a very special thanks to all the speakers who helped us to gain more knowledge in various fields. Thank you.
Good afternoon, everyone. The session was very useful and also interesting. We were able to collect a lot of information mathematically and also from different topics like image processing, decision analysis, etc. I sincerely thank Kongunadu Arts and Science College and Bannari Amman Institute of Technology for organizing this international conference in an effective and productive manner. Thank you once again.
Good afternoon, everyone. I am Jeevita, first MSc Mathematics from Kongunadu Arts and Science College, Coimbatore. This is the first time I'm attending an international conference. It's really a new experience for me. This is very much useful and informative for me, and I hope it feels same for all others too. Thank you for organizing this conference. Thank you.
Kartika. This is my very first international conference, and all the speakers shared a lot of valuable information, and we get to know about something new in these 2 days of conference, which should help us to proceed with our future research. Thank you so much for the opportunity.
Good afternoon, everyone. I'm very grateful to be in the midst. I appreciate the presentation. It is very informative. I am expressing this highly in the first time of its kind, and I really enjoyed and appreciate, and I learned so much. I will be very happy to have a mentorship orientation with the presenters in the future reference. Thank you very much.
Any other feedbacks?
Good afternoon, everyone.
Yes, ma'am. Good afternoon.
Good afternoon, everyone. It was really a knowledgeable session from my side also. On both the days, the lectures you conducted was very knowledgeable, and we learned so many things from these lectures. Thank you. Thanks a lot, ma'am.
Thank you for your kind words, ma'am. Any other feedbacks? The most beautiful way to start and end any occasion is with a grateful heart. I now invite Mr. M. Karupasamy sir, Assistant Professor, Department of Mathematics, Bannari Amman Institute of Technology, to propose the vote of thanks. Sir, please.
Thank you, Kartika. Good evening, all. I am Karupasamy from Bannari Amman Institute of Technology. I feel honored and privileged to get the opportunity to propose a vote of thanks of this special day. So this is the proudest day in the history of our department. We have hosted the biggest education conference with 220 paper presentations and 400 participation from colleges and universities across all streams of education, and 67 participations from 11 countries outside in India. On behalf of Bannari Amman Institute of Technology and Kongunadu Arts and Science College, I convey my regards and heartily thanks to our Principal, Dr. C. Palanisamy, Dean, Dr. K. Sivakumar, Head Research Development, Dr. P. Jagdiswaran, Head Academics, Dr. K. L. Sendilkumar, and the Principal of Kongunadu Arts and Science College, Dr. M. Likesh Manasamy, Dean Academics, Dr. S. R. Madan Sankar, Dean Research Development, Dr. S. Palsamy, and the chief guest of our from the various countries, international advisory committee members, chairpersons for the presentation sessions, paper presentation and participants from the various institutions, convener Dr. M. Parimula and Dr. V. Kogilavani, organizers from Bannari Amman and Kongunadu Arts and Science College, student members and department members of Bannari Amman Institute of Technology and Kongunadu Arts and Science College. I thank Bannari Amman Institute of Technology Management and Kongunadu Arts and Science College Management for supporting this conference. So thank you all. Thank you so much for attending this session, this conference. Thank you.
Dear participants, the feedback link is posted in the chat box. You can fill it now. The feedback link is posted in the chat box. You can fill it now. The paper presentation sessions are arranged parallelly, and we request the participants to join in their respective meeting links and proceed with your presentations. I repeat, the paper presentation sessions are arranged parallelly, and we request the participants to join in their respective meeting links and proceed with your presentations. Thank you everyone for attending this 2-day virtual conference. We hope you had a great time. Stay safe and take care. Thank you.